Okay, so hello guys, welcome again to another discussion video with your strength of materials. Now, since we already done discussing with your normal and shear stress, right? So we know that we have your normal stress, which is a function of your normal force, right? That is perpendicular to your area. Now, also for your shear stress is we can have your double shear if the member is under double shear or it can be on single shear. So the same gihapon, that is a function of your shear force, but that is parallel to your area. Okay, so since we already done talking with that, so we can now proceed to our basic structural analysis and design. So whatever that you will be learning here, all right. So whatever we will be discussing in this video is that would be the basic, right? So if you are going to go with your design subjects, all right, and also your theory of structures, you will be having the idea na karon pa lang you will be having the idea on how do we design structures, right? So the basic, and we will be using the concept of your stress, which will be your let's just say that would be your determinant, all right, if your structure will fail or not. Or in general, you will just design structures because that would be our main goal. You should design structures in order to avoid failure. Okay, so without further ado, let's just proceed to our discussion. Okay, so in this video is we are just again to talk about the basic structural analysis. So we are going to analyze and design members subjected to axial load or direct shear. So just a design, mag-design tag structure to resist the applied loads. It can be axial load or it can be a shear load, right? So depende. Okay, so before that is we're just going to discuss first what is allowable stress. So allowable stress, this is the purpose of this one is to when we properly design, okay, to properly design a structural member or mechanical element, it is necessary to restrict the stress in the material to a level that will be safe. Okay, of course, all right, that is the purpose of us engineers, that we should build structures that are safe, right? Safe to resist the applied loads. Depende kung sa siya, para sa siya gamiton, so dapat dili siya mo fail gyud. That is our major priority, right? Our utmost priority, the safety. Then to ensure the safety, it is therefore necessary to choose an allowable stress that restricts the applied load to one that is less than the load the member can fully support. So what does it mean? If you're going to analyze structure, dili na nimo pwede kung unsa ra ang load diha, mura po nimo gamito. No, you should have allowances. Mamagin na siya. The same sa deadline. Nabasa ko pag ginasuti before. The same sa deadline. You are not if you are given with a deadline, right? It is not really safe nga imo sagaron ang deadline. Mo ang deadline diha ra pud ka magtrabaho kay nga naman kung na kay mga uncertainties, right, ka na mga wala ka nakabalo. Excuse me. If ka ng mga wala ka mga undesirable nga mga happenings, so naay mahitabo diha, so delikado ka, all right, if imo isagadon ang deadline. The same also with your structure. You do not design structure for that specific load only. Dapat naapa kay allowable na stress or load kay para na kay allowances for your structure. One method of specifying the allowable load for a member is to use a number called the factor of safety. Now, the purpose of that is daghan there are many reasons nga nung need ta mag-provide of factor of safety. Ang uban diha is first inappropriate loading, right, as per design. So nag-design ka ani nga structure tapos naay mga changes especially sa ato ang mga loadings na dili na nimo project tanan. So there are many changes, all right, sa ato ang mga loading as per design. Design is very different sa actual na gyud, right? Nadyo na sila mga discrepancies. So lahi sa imong gi-expect, so that would affect your loading. Na kung if ang imong design is para ra gyud diha nga load, wala kay allowances for the variation and for changes, so delikado imo siya structure. So that is why you should provide factor of safety kay para makater to nimo siya nga unexpected loadings. Then we can also have the measurements were not followed. For example, your beam is 400 mm depth tapos 250 mm wide, right? Mo na imong dimension sa imong beam, 250 by 400. Tapos if you can observe, I don't know if naka-observe na mo sa site, it is not really perfectly nga naka-shape siya as in 400 by 250 gyud na siya, right? Dili gyud na siya always nga perfect because nothing's perfect, di ba? No one's perfect. So tungod ana, if you have no allowances, so ang instead nga 400 nahimo siyang 350, imong 250 nahimong 200 na lang, di ba? Naibanan. So it may affect your design. If wala kay mga allowances, then delikado na siya. That is why for our designs is ato ginagamit si factor of safety unsa pay lain mga unknown vibrations, right, or loading or the same gihapon accidental loadings kanang naay mga mahulog ba kaha, alright, mahulog ba kaha. For example, nag-design ka og lahira ang bull, lahira ang sana siya sa example, lahi ang effect sa usa ka kilo nga lansang, right? Lansang na lang. Sa kilo nga lansang, lahi ang effect sa structure kung ang usa ka kilo nga lansang kay imo ra gibutang ug ang isa ka kilo nga lansang is imong gitagak sa babaw, right? Impact or naay mga unknown vibration, alright? Unknown siya nga nang lahi ra ang effect sa imong ibutang ra diha ug sa imuhang ihulog. Of course, by physics, mas dako gyud og impact ang nahulog, diba? So, if wala na nimo siya na predict, wala kay factor of safety, then again, delikado imo structure. And also for atmospheric corrosion, mga weathering, decays, right? Your material decays, especially kanang mga exposed to atmosphere and to weather, so it may affect, right? From time to time mo change nang iyahang capacity. Now, if wala na nimo siya na predict, wala nimo siya na appeal, so again the same gihapon na siya effect. Now also especially ang ato ang wood and concrete, alright? Ang ato ang wood, especially ang wood, kabalo man kita that wood is weaker when it comes to weather, right? Daghan siya maapektuhan gyud maayo si wood, especially if weather mo na nga natin mga treatment. Pero mo nagyugihapon siya, maski imo na siya i-treat, na gyugihapon na siya effect sa ato ang wood. And also for concrete, alright? Napon na siya mga maka-affect sa ihang strength. For example, depende sa pagtimpla, tanan. Depende sa imong pagka-mix, depende sa imong mga material nga gipanggamit sa imong concrete, so maka-affect gihapon na siya sa strength. Now, if maski sa design mingo sa design nga okay, ang ako ang design sa akong concrete is 30 megapascal, right, or 30,000 PSI. So, kanang imong design is that would not be achieved good sa actual. It can be sobra or it can be kulang. So, naagyon na siya mga discrepancies. And basic example diha sa tulay, diba? Sa tulay is natay mga ingon diha nga 15 tons, diba? Nata, I don't know if nakakasway na nakakita na siguro mo ana, right? Since birth, right? Since birth. So since birth makakita na mo ana. So natay mga 15 tons, natay mga 20 tons. So kana nga mga load ipang butang diha is dili jud na mao ang maximum, alright? Dili na siya mao ang actual nga loading. Kaya nga naman, for example, natay mo agi nga sakyanan nga say, sa ang capacity is 15 tons. Tapos, what if naisakyanan nga moagi og 16 tons? Mabong kag diretso ang tulay, di ba? Delay. Because naapa na siya yung mga allowances. Now, they have applied the factor of safety in that case sa ato mga design. Alright? So, appropriate factors of safety must be considered when designing your cranes. Alright? Kana nasa ubos. Right, kanang mga cranes na to, i-design po na siya. And also for cables that are used to transfer heavy loads. Right? So, mo na siya mga factor of safety nga to nga applied. Okay. So, what is your factor of safety? Yun. So, the factor of safety is stated mathematically is, if ato siya gi-state mathematically, your factor of safety is equal to your failure force, meaning at that specific force mo fail na dayon ang structure over the allowable force, meaning ang iyang allowable, so unsay buti pasabotan niya, sir, meaning fail, right? Failure force, that would be your equivalent to your maximum, right? Maximum force mga naragyo na siya taman. If mulapas ka diha sa ato ang failure force, sa ato ang maximum force, failure na jud na ka. Alright? Now, what is your allowable? Meaning na kay allowance nga gibutang, alright? Ang allowance yun na nimo gibutang ano man, dili na nimo siya pwede sa garon yang imuhang allowable equal to your failure. Kaya nga naman, dili na siya safe. Okay, for example, right? Dapat na kay allowance. For example, mag-drive kag sakyanan or mag-drive kag motor. Di ba dili jud ka mo dikit mo ni sakyanan, diha jud ka sa pud sa diha pud ka sa lubot sa imong sakyanan, di ba? Dili. You should have space. Nga naman, kay in kaso mo break ni nag-una, dili ka diretso bangga. Kay kung imo na siya sa garon, alams na, di ba? So, that is same is true with your structure. Kung pila iyahang allowance or pila ang iyahang maximum force nga kaya, dili gina nimo siya sagadon. Dapat naa kay allowance, alright, for safety. Now, engineering tells us, alright, in engineering, it tells us that we must not use the ultimate values. Maog yun na inyong hinumduman always. We should not use the ultimate values. We should limit it, alright? Ato na sila limitahan kay para diha ra sila taman. Alright? Di na sila mulapas dito. Kay in kaso mulapas sila sa imuhang allowable, naapa kay allowance nga dili pa na mo fail imong structure. Right? Pero in every situation, there may be another values of factor of safety. So, depende na siya. Alright? Lahi-lahi na siya factor of safety. Now, for example, sa ato ang foundation, sa geotechnical engineering, right? So, geotech is usually the value of factor of safety that is used by our geotechnical engineers is 3. Sa ato ang mga geotech na mga problems, ang atong factor of safety usually diha is 3. Right? Because soil is very uncertain manggod. Maglahi-lahi na siya. So, because daghag uncertainties ang ato ang soil, so muna nga 3 ang atong gamiton because of its property. Okay? So, muna siya. And also, in many cases, right, especially sa ato ang mga structural codes or references, there are specific values of factor of safety na ila pwede ipagamit sa ato for the design just to ensure safety. So, na siya, naka-state na siya sa ato ang structural code. Okay? So, but since load is linearly related, diba? Because force, because we have here because our stress is equal to force over area, diba? So, area sigma is equal to F, or linearly, alright? Mo increase si stress, mo increase po si force because they are linearly related. Meaning, kung mo increase si force, mo increase po si stress. So, therefore, we can just express in terms of stress. Alright? Ang ato ang factor of safety. Now, for your normal stress, right? For your normal stress, we have your failure stress over your allowable stress that would be equal to your factor of safety. Now, for your shear stress, that is equal to the same gihapon, your failure shear stress over your allowable shear stress is equal to your factor of safety. So, if ato na siya manipulate, we will be having, say for example, your failure, right? Your failure is just simply your allowable, T allowable, multiplied by your factor of safety. For example, right? For example, nakay tulay, right? Nakay tulay nga ang iyahagyod as per design, alright? Sa iyahagyod, ang iyahagyod actual, alright? Ang iyahagyod actual is 3,000 kilogram or 3 tons, alright? 3 tons na lang. 3 tons. Tapos ang iyang gigamit diha nga factor of safety is 2, for example, 2, right? Ang naka-display sa tulay, labay kay tulay. Alright, sige, kanina na action na lang, 15 tons na lang, 15. Labay kag tulay nga na ay nakabutang 15 tons. Now, say for example, natay nagamit tag factor of safety nga 2 diha nga part. So therefore di ay kung 15 tons ang nakabutang diha, this is just simply your allowable, alright? Allowable lang ni siya. So 15 anan. Your allowable is equal to your failure over your factor of safety. Kanang atong 15 tons nga naka-display diha, that is only the allowable. That is not the maximum or the failure load. So therefore, if not a factor of safety nga to, this would be 15 tons, right, is equal to your failure over your factor of safety, which is 2. Therefore, if natay tulay, for example, nga nakabutang 15 tons, tapos natay factor of safety nga 2, kaya pa na niya i-cater ang load up to 30 tons. Right? Meaning, mo na atong gamit sa factor of safety. Instead nga 30 tons ang ato ang gi-display, 15 tons lang. Ano man? Kaya kung 30 tons na imong gigamit, what if mo 31? What if mo 32? What if mo 30.5? What if sabot? Failure dayon ka diretso. Pero kung ang imuhang i-display, mabigyan na ang mga tao, di ba? Kung sa i-display, dili gyud na nila sundon. Mulapas pa gyud na. So that is also the reason nga natin factor of safety. Okay, for example, kung 15 tons nga, 15 tons bitaw ang kaya ani, so pwede pa nag 15.5. Right? So maski mag 15.5 ka, mag 20 ka, mag 25, mag 29, right? Pwede pa na siya because your failure is up to your 30 tons using the factor of safety nga to. Right? So that is the concept of your factor of safety. So I hope nga klaro lang. That is, again, the purpose of that is for safety and allowances. Now, the factor of safety must be greater than 1 to avoid potential failure. Right? Nga naman, if that is equal to 1, if you are going to use factor of safety is equal to 1, your failure would be equal to your allowable, which is, again, not safe. Right? Not safe if we are going to use factor of safety nga 1. So, nana sa mga 2, usually 1.5, 2, 3, na. Muna yung mga factor of safety nga atong usually nga ginagamit. Okay? So, for the design design of simple connections, right? So, in particular, if a member is subjected to normal force at the section, its required area at the section is determined by, first, we just manipulate the equation for your normal stress, diba? Your stress is equal to force of your area. Therefore, if wala ka kabalo sa area, because again, we are doing design. Meaning, design gani, ikaw ang mag-determine unsay dimension. So, therefore, area ang unknown. So, you know, the force is given, the allowable stress is given, so you are going to design the structure or design the area of the structure or the member itself. Okay? So, by this formula, so ito lang siya manipulate. On the other hand, if the section is subjected to an average shear force, then the required area of the section is, again, using your shear allowable. Okay? So, by making simplified assumptions regarding the behavior of the material, the equations derived for sigma and tau, alright, kaning sigma nato and tau, can often be used to analyze or design a simple connection or mechanical elements. So, bisag unsa a member, a structure, or what. Okay, so as discussed sa atong previous nga video, the allowable stress used in each of these equations is determined by applying a factor of safety. Right? Sorry, sa lahi dito nga subject. Sa design subject na dito because I am handling steel in this semester. So, sa lahi dito na ako nga na-discuss ang factor of safety. So, diri na lang, since nag-isgot naman tag factor of safety, okay? So, ang atong allowable stress is a function, right, by applying factor of safety. We are going to apply factor of safety diri to the material's normal, both normal and your shear failure stress, okay? And then, we are going to find this stress directly from an appropriate design code. Or usually given man yun na ang ato ang mga allowable, ang ato ang failure stress. Depende sa materials. Alright? Depende sa itong materials ng gamiton. So, one method of specifying the allowable load for a member is to use a number called, again, the factor of safety. Anyway, we'll be having examples later so mas makagets mo unsaon paggamit si factor of safety. So, important points. Okay, for some important points, in designing a member for strength, right? For materials that we are going to use in your structures, select an allowable stress that can safely support its intended load. Now, usually that is given. Now, if you are going to do sa designing na, right? We are going to go with your steel and reinforced concrete design. Is usually you are the one who are going to investigate kung unsa ang iyang intended load. So, ikaw ang mga design kung what are the loads that are applied on the structures, again, by using your structural code. So, since this is just simply an introduction, so usually the allowable stress is given. Okay, given na siya. So, use a factor of safety to obtain the allowable stress, then the member can support from your actual failure stress. Now, if you have the allowable, again, the same happen using the equation. If you have the allowable, you're just going to use this equation. Say, for example, normal stress fail, and then your normal allowable. Okay? If you have allowable nga given, right? Usually given man ni siya. Tapos napog kay factor of safety. So you can just solve your failure. Kani si failure, this would be the one that you are going to use during your design. Si design na usually ang gamiton. Sorry. Sa design ni siya gamiton. Ang ato ang failure stress. Okay? Kay para ang atong, okay, kagets mo sa logic. If si failure ang atong gamiton sa design, maski ang atong allowable is ingon-ani lang siya, right? Maski ang atong allowable is ingon-ani lang siya. Na yung mga discrepancies sa ato ang load is safe siya because again, our design is si failure. So kung malapas ta gamay ni allowable, okay lang na siya. Again, the same logic ganina sa tulay nga akong gi-example, right? Now for analysis, right? For analysis is baliktad. Si allowable ang atong gamiton sa analysis tapod, right? You will know that when we will be doing examples. Okay? So, procedure for analysis. First is you are going to carefully consider the section to which the critical stress is acting or kung asa nimo gusto i-design nga member. So, kung asa ka nga member gusto mong design, then you are going to determine alright, kung kanang area, right? You are just going to specify kung asa nga area imuhang gusto i-design. Now, if you have selected the area, then you are going to design the sufficient area, right? So, imo na kaon kung unsa ang area nga dapat to resist the stress acting on it. So, unsaon man nato pag-design ng area? First is you are going to determine the internal forces. So, kabalo naman ka, alright? Kabalo naman ka kung asa siya makitaan. So, you are going to solve for the internal force on that section or on that area. Both kung naay axial, so si axial, kung naay shear, so si shear. Alright? So, depende kung unsa available, kung unsa imong design nun. Normal ba or shear stress ba? Okay? Now, if you have already solved for the internal forces, is of course using the formula, right? Using the formula which is area is equal to force over your sigma or equal to your force over your tau. So, depende kung unsay gamit, allowable shear ba or allowable normal stress. Now, you are using this formula, you are going to solve for the area ng gamiton. Okay? So, unsa may mga hinumduman nato dire? For area, right? For area, usually, atong gamiton dire is na ay rod. Kabalo mo sulita the area of rectangle, di ba? Rectangle na to is basic area. For the pipe, ang usually listed dire is si pipe. Your pipe is just simply your area outside minus area inside. Because, di ba mo na ito pipe? Natay pipe diha. Di ba hollow ni siya? Right? Hollow man ni siya. So, therefore, ang kaning dako, iba na nimo sa kaning gamay. So, outside minus inside. So, ang iyang simplified formula diha is using diameter, that would be 0.25 pi d squared. Out ni siya ha? D out minus D inside or inside diameter. So, that would be the area of your pipe. Okay. So, I hope maklaro lang because that these sections, these are the common sections that we are going to use in this course most of the time, right? Pero kung solid, very easy lang na siya. I know, kabalo na mo ana. Okay. So, let's proceed with example 11. Okay. So, wait, let me just set up our solution board. Okay, so the control arm is subjected to the loading shown. Now, we are going to determine to the nearest 1/4 inch the required diameter of the steel pin at C if the allowable shear stress for the steel is 8 KSI, right? So, that is our allowable stress. So wait, let me just set this up. Okay, so let's proceed now to our solution. So, kung na siya i-close. Okay, so we have here your structure. So this is based on the question, we have, we have a control arm. Okay, control arm. And let's just copy the given. We have your allowable shear. Eight KSI. Ano na siya? Medyo naka-italic mo na akong text. Or okay, so your allowable is equal to 8 kips per square inch or 8 KSI. So okay, so first is since we are nearest 1/4 inch, so ato siya i-round off to 0.25 inch. Depende kung unsay pinaka-close. Okay. So first is since we are going to design your control design the required diameter of the steel pin at C. So at C, so therefore we are going to determine kung what are the forces or the forces acting at point C. So in this case, this is just simply a hinge connection. Hinge connection siya, so therefore we have your AY here and we have your AX here. Okay. So let's just do summation of moments. Okay. Masolve na nato siya summation of, para need ba ni nato masolve siya? Your BA. Right? Summation of moment at C. Clockwise moments are positive. So therefore, clockwise moments, we will be having 3 multiplied by medyo awkward lagi ang handwriting na ko ron. Okay. So, we will be having 3 multiplied by 3 inch. Isa pa laing clockwise diha. We have here 5. Kaning 5 kips. Then, the Y component is 3/5. The moment arm is 5. Since kaning iyahang horizontal component is dili man siya mo moment sa C, kay mo agi ra man siya. So, wala na tayo lain, di ba? Minus BA. The moment arm is 8 is equal to 0. Therefore, what is the value of our BA? We have your 3 times 3 plus 3 times 5 divided by 8. So, we have 3 kips. Okay. So, we have here 3 kips. Ako na siya at diri. So, therefore, we can now solve your AX summation of forces X is equal to 0. To the right, forces are positive. So, we have your AX plus your 5 times 4/5 sa pelain minus 3 kips. That is equal to 0. So, I guess wala naman siguro tayo horizontal forces. So, we only have your AX, which is equal to 3 minus 4. That is equal to -1. So, therefore, padulong dahil siya dito. Okay, that is -1 kips. Now, for the summation of forces y, summation of forces y is equal to 0. Upward forces are positive. So, therefore, we have your ay minus 3 minus 5 multiplied by 3 over 5 is equal to 0. Therefore, your ay is equal to 3 plus 3. So that would be 6 kips. And that is upward. Oops. Therefore, what is our resultant reaction at C? Ang ano A? Supposedly C na siya. Anyway. Okay? So, resultant reaction, that would be your, sige, ikaw na lang. Your resultant reaction at C is equal to AX squared, since na AX naman na siya, plus AY squared. Therefore, what is our C? The square root of 1 squared plus 6 squared. That is equal to the square root of 37 kips. Or that would be approximately be equal to 6.083 kips. Okay. So, nanatay internal force nga na-solve, diba? So, this is our internal force that is acting on the what? On the pin, right? On the pin at C. So, since na naman tayo force, we are going to design your pin using the concept of your stress, right? So, what is our working equation? We will be having area is equal to your force over your area. Okay? Force over allowable shear. Alright? Force over your allowable shear. Now, first is we are going to determine that the force, right? Our force nga na-solve is 6.083. Muna siya ang force acting at point C. Kung ato ni siya okay? Kung ato ni siya design, right? This would be our C. Then this is unsa man ni siya? Pila man ni siya ka shear? This is double shear, di ba? If this is double shear, therefore, your 2V is equal to your F. Alright? Okay. Since shear man ni siya, ang atong gamiton diri is V. Sorry, V. V ato gamiton ha because that is shear. So, because this is double shear, your 2V is equal to 2F. Alright? So, therefore, V is equal to F over 2. So, what is our V? That would be 6 square root of 37 divided by 2. That is equal to 3.041 kips. Okay? So, that would be 3.041 kips. So, since na natay internal shear nga magamit, this is our internal shear nga magamit, di ba? So, we can now design your area. Now, what is our area? We have your 3 point, ako na lang siya ikon ha, ang exact value that is equal to square root of 37 over 2. Muna ang iyang whole nga shear. Then, what is our allowable shear stress? That is 8 KSI. This is 8 kips per square inch. This is in kips. Di ba? Kips man ni siya. So, therefore, makancel si kips. Now, ang ma-answer natin dari area would be equal to square root of 37 over 2 divided by 8. Now, the answer would be 0.38013. The unit is in square inches. Okay? So, nanatay area, therefore, the question is the diameter. Alright? Required diameter. So, since diameter man na siya, we know that the area of your circle is equal to 0.25 pi d squared. And that is equal to 0.38. Alright, ako na lang gamitin ng whole value. The whole value is equal to the square root of 37 over 16. And that is equal to 0.25 pi d squared. So, therefore, we can now solve your diameter by solving the square root of Square root of 37 over 16. 1 over 0.25 pi. Manipulate lang, alright? We are just going to manipulate the equation. Therefore, what is our diameter? The square root of 37 over 16 multiplied by 1 over 0.25 pi. So the answer is 0.696 square inch. Right? This is our answer. Pero ang iyang giingon, alright? Ang giingon sa question is, we are going to design the diameter to the nearest 1/4. So, kung to the nearest 1/4 na, unsa man siya? 0.25, we have 0.5, 0.75, di ba? Si 0.16 na, nasa man mo siya? 0.5 or 0.75? Kung imo na siya 0.5, it would be less than. Alright? Kung mag 0.5 ka, ang imuhang area nga ma-produce ka ron would be less than this one. Alright? So, therefore, hinumdumi na siya. Kung design gani, always jud ka round up. Alright? Kung design, always jud ka round up. Dili ka pwede mo round down. Nga naman, of course, designer ka, hinumdumi na siya. If mo round down ka, mo fail imuhang structure. Okay? Again, ang imuhang design is kani, pero imo siya pagamyan, of course, from 0.6 to 0.5, di ba? That's very wrong. So, therefore, always ka round up. Therefore, our design diameter would be 0.75 inches. Sorry, nga no, dili na siya square inch, inches lang na siya. Right? 0.75 inches. Ang ato ang working diameter sa C. Now, let's check if we have the same answer. What is our answer? We have 0.75 inch. Okay, so we have 0.75 inch for our pin at C. Okay, so I hope nga klaro ra. Okay, so now we can now proceed to our next example. Again, if you have some question, all right, feel free to ask. Now, the suspender rod is supported at its end by a fixed connected circular disc as shown. Okay? If the rod passes through a 40 mm diameter hole, determine the minimum required diameter of the rod and the minimum thickness of the disc needed to support the 20 kN load. Now, the allowable normal stress for the rod is 60 MPa. And the allowable shearing stress for the disc is 35 MPa. Okay, so let me just copy the figure kay para makaproceed ta sa ato ang solution. Okay, so let's proceed to our solution. So the suspender, we have allowable normal is equal to 60 MPa. Then the allowable shear is equal to 35 MPa. Again, remember that this is MPa, so therefore we are going to use force in Newton, right? And our area in mm squared para diretso. So the problem here is we are going pila daw ni, alright? Kaya nga naman, unsa may possible nga mahitabo dire? If we are going to apply the 20 kN load, right? Hinumdumi ni siya. If we are going to apply the 20 kN load here, there are two possible scenario nga mahitabo. First is possible maputol ni siya at this point. Alright? Kung kusog kay ni imong 20 kN load, kaning rod nimo diri is maputol, alright? Or ang usa, if ligon kay ni imuhang rod, mabuho ni siya at this point. Since buho man ni siya, di ba? 40 mm ang gud ni siya. So therefore, mahimo ning donut, right? Ma-donut ni ang imuhang plate sa babaw, right? Ang imuhang disc sa babaw. So muna ang duha ka senaryo nga possible mahitabo diha. So now, we are going to design to prevent the occurrence of those two scenario. Meaning ato i-prevent nga dili ni siya maputol, ato pod i-prevent i-design siya using the thickness nga dili po ni siya mabuho. Ano man, ngano thickness man sir? Kabantay mo, if baga ang isa ka butang, dili ni mo siya madali-dali og buho, right? Mas baga, mas dugay siya mabuho. Diri pod, mas dako siya, right? Dugay siya maputol. Okay, so mas dax, char. Okay, so let's proceed with our design. So therefore, if this is 20 kilonewton, kabalo ka nga the forces acting diri nga system is only 20 kilonewton or 20,000 Newton, right? 20,000 Newton. So first, let's design for the rod, right? For the rod, we have your area, right? Para dili mo maglibog, right? Para dili mo maglibog sa daghan formula. Ang ira naman diha is sigma is equal to force over area. Stress is equal to force over area. Manipulate na lang ka diha. Alright? Diha ra maghapon na tanan sila. Okay? So, sigma is equal to force over area. What is our allowable sigma? That's 60 MPa. 60 Newton per mm squared. Diba? That's 60 MPa. Now, the problem here sa rod is we are going to design your diameter. Now, what is your force? Okay, what is your force? That is 20,000 Newton. What is your area? Area of your rod is just simply 0.25 pi. That is the squared. The unit should be in mm squared. So, makancel sa mm squared, right? Kana, Newton. So, therefore, kabalo ka that the unit of your diameter is mm. Kaya nag-mm squared na good ka. Pero anyway, wala pa man kay mm day para di malibog. Ako lang sa siya i-delete at tangtangon. Kaya aron dili ma-eliminate si mm. Para makasubay yun mo. Right? So, mahabilin dere is mm squared. Okay. So, let's just manipulate the equation. This squared now would be equal to pila? That would be 20,000 divided by 25 pi times 60. This would be equal to 424.4132 mm squared. Therefore, what is our diameter? What is our diameter? That is equal to the square root of the answer. That would be equal to 20.601 mm. Okay? Kung ikaw designer, dili ka pwede mag 20.5, 20.2. Again, dili jud ka pwede mo round down. Right? Di ka pwede mo round down, especially if you are doing design. Okay? Round up jud ka diretso. Kung gusto siya buo, so that would be 21 or 20.7. Alright? Kung ingana. Okay, so this is the diameter of your rod para dili siya maputol. Now, how are we going to design your disc para dili siya mahimong donut? Alright? So, if that is 40 mm, alright? If that is 40 mm, di ba this 40 mm nga, ato siya i-top view. Top view na ha. Okay. Assuming circle na siya. Assuming circle. Okay. If this is 40 mm nga diameter, ang imuhang failure plane karon, right? Your failure plane would be along this circumference, right? Meaning, ang kaning imuhang 40 mm is sa circumference siya pwede ma-fail. Now, what is the failure in that case? Di ba shearing na siya? Shear meaning magisi siya all throughout your diameter. Okay? Kay mura ra siya gigisi nimo ang plate sa tunga para mahimo siyang donut. Therefore, ang imuhang gina-resist diri nga stress along the circumference is shearing or shear stress. Shear stress. That is why we are given with allowable stress which is 35 pila to? 35 MPa. Okay? So shear is equal to your shear force over your area. So what is your shear force in this case? So obviously, your shear force is just simply kung pila ni nga force, that is 20,000. That is 20,000 Newton. Now, what is your area? Unsa man ang area nga ga-resist? Again, your shear force, dapat ang area gina-consider nimo sa shear force is parallel. Now, what is the area parallel to this shear force? That would be equal to your circumference. What is the circumference of a circle? That would be pi d, di ba? That is pi d circumference multiplied by your thickness. Kung ato na siya i-flat, ato na siya kanang imo circle, ato na siya i-side view. Ang area karon nimo would be your pi d, meaning the circumference of your circle and the thickness, right? The thickness t. So sila kani nga area karon mao imo resist nga dapat ang imuhang disk is dili siya may undergo og shearing failure, right? Dili siya magisi or di siya mahimong donut. Now the area that you are going to consider is pi d, right? Pi d multiplied by your circumference. Basta kailan ang circumference multiplied by your thickness t. So therefore, na naman tingin ani, masolve na din nato si thickness because we have the allowable stress of 35 Newton per mm squared. Okay. So we have here 20, makancel si Newton, right? Makancel si Newton. This would be 20,000 over pi. The diameter of your circle is 40, di ba? 40 mm. 40 mm. So therefore, this would be pi 40 mm multiplied by t. So therefore, maiba na ng isa ka mm. Himo siyang 35 over mm. So, there is a strength of materials. Usually, ang imo lang yun clue kung sakto imo answer is you play with the unit. Kung sakto ang imuhang unit, meaning na possibility nga sakto po imuhang answer. Okay? Play with the units. So, since sakto, mm ang mahabilin din, ang imuhang gipangita is thickness. So, sakto ang imuhang manipulation. So, thickness is equal to, manipulate na lang ka, that would be 20,000 divided by 35 times 40 pi. Wala naman is mm, di ba? Makancel po ng isa ka mm. So, mahabiling karon would be 4.547 mm ang mahabilin. So, therefore, this would be the thickness of your disc to avoid shearing. Okay? So, I hope na nakasunod for the solution. So, you just go back sa video if wala to review kung di nagikan ang ako ang solution. Now, let's check if we have the same answer or we have the correct answer. We have 20.6 for the diameter and 4.55 for the thickness of your rod. Okay, so for any question again, please do ask para mas matubag. Okay, so let's proceed with the next example. Okay, the shaft is supported by the collar at C, 3, which is attached to the shaft and located on the right side of the bearing at B. C, collar C. Okay, dara, kining murag silver. Gi-attach siya diri ni B. Kay para dili ni siya maibot. Alright? Dili ni maibot. Kung ako ni siya birahon pa doon dito, dili ni siya maibot. Which is attached to the shaft at located at bearing B. Determine the largest value of P for the axial forces at E and F. Alright? Nag-apply ta diri og P. Dapat nag-apply po diri og 2P. so that the bearing stress on the collar does not exceed an allowable stress of 75 MPa, and the average normal stress on the shaft does not exceed an allowable stress. Okay, so unsa may possible diri nga mahitabo? If this is 20 collar. Okay. So, mura siya og, later na. Okay, so let me just copy the given para magdungan tag-solve while I'm figuring out kung saan siya pag-solve. How are we going to design this system? Okay, so let's proceed with our solution. So we have here your system. So let me just copy the bearing. For bearing, we have 75 MPa. Then for the normal stress, right? Normal is we have 55 MPa. Okay, so what else? What are the other givens? Okay, so I guess wala na siya. Okay, so for the bearing, how are we going to, since natagit, okay, naman gitagaan man ta diri og bearing og normal. Therefore, there are two modes of failure in this one. First is the bearing failure at C, right? Bearing failure at C, wherein unsa may mahitabo kung mo fail si C. Tungod kay bearing, for example, kung kusgan kay ni si B, alright? Kusgan kay ni ang mga forces nga naa diri. Kaning ato ang color si C, right? Kanang color ni C is it's either madugmok ni siya, alright? Madugmok ni siya due to bearing pressure, alright? Due to bearing stress, madugmok ni siya. Or, alright? Tulo din ni ka case. First is na possibility nga madugmok ni si C, right? Madugmok si C tungod kay kusgan kay ni si P. Ikaduha, na possibility nga mabuho niya ang ato ang bearing diri, meaning maibot gyud ni siya, matangtang ni siya, mahimo ni siyang donut, right? So kung mao ni ato ang bearing, nakingana ni ato bearing atong nakingana na siya, na possibility nga maibot ni siya kaning murag circle, kana si color, right? Maibot ang atong color kung lig-on kaayo si color, meaning dili siya madugmok, right? Mas mauna po mo fail ang bearing kaysa ni color. So, mo na ikaduha. Again, first, madugmok. Ikaduha is maibot. Good na siya. Ikatulo is maputol. So, muna ang mga cases nga atong gina-investigate. So, ang first two cases, katong madugmok or maibot, that is because of your bearing stress. Alright? Due to contact, meaning kani si bearing, alright? Kaning ato ang kani siya, kaning naa-DB, kaning muragin ani, o kaning si color is naa na sila'y contact surface. Alright? Contact surface that has a dimension of 80 mm nga diameter. Kay color man siya, so naka-circle gina siya, di ba? Naka-circle gina siya. Therefore, naa ni sila'y contact, which is due to bearings, na sila'y contact, therefore, makaproduce sila diha og bearing stress. Okay? So, that is the first and second situation. So, second is, of course, mag-gets din na ninyo. That is a normal force. So therefore, magkuha kag section diri, magkuha pa kag section diri. So asa may mas dakog possibility nga mo fail. Of course, kani ang imuhang designan. That's problem. Determine the large value so that the axial forces at E and F so that the bearing stress on the collar does not exceed the allowable stress. Okay. So, natay tulo ka case diri. Wala ito. Matong tulo ka case, di ba? So, ang ato ang, kanos amanin maputol ang ato ang rod, kaning shaft na to. Di ba? Ang ato ang if magkata diri og cross-section, ako na siya ibalik. If magkata diri og section, ang maproduce nato diri nga section is 2P pod. Right? 2P nga tension. Diri, ang makuha nato diri nga section is P lang. Therefore, ang critical nga section nila duha is si 2P. Alright? 2P ang pinaka-critical nga internal force. Kaya nga rin, P raman, diri, 2P man yun siya. Alright? As per method of sections. So therefore, ang ato ang gamiton nga quandary force sa ato ang shaft is 2P. Diri, we have your bearing. What is the force that we are going to use sa ato ang bearing? That would be 2P plus P. Therefore, ang ato ang gamiton diri would be 3P. Okay, so first situation, due to bearing. That would be stress is equal to force over your area. Okay, we have the allowable bearing stress, which is 75 mm. That would be 75 Newton per mm squared. Now, what is the force due to bearing? That would be 3P. Over. What is the area? The contact area. Alright? Area gani meaning contact area. Bearing man ta, bearing. So, contact area na siya. What is the contact area between the collar and the bearing? That would be circle na siya. That would be 0.25 pi, the area of the circle. The diameter is 80 squared. The unit is in mm squared. So, therefore, makancel si mm squared. Now, what would be the answer for our P? Right? 75 Newton multiplied by 0.25 pi over 80 squared divided by 3. Therefore, the unit would be 125,663.706 Newton, or that would be approximately equal to 125.66 kilo Newton. So that is due to bearing. Now, what is due to normal stress? Due to normal. That would be stress is equal to force over area. Now, for your normal stress, we have allowable normal stress that is equal to 55 MPa. So, 55 normal over your squared mm. What is the force nga atong gina-consider? Duha man ni ka section. Section AE and section EB. So, therefore, again, atong investigate mas dako si section AE, which is 2P. So, therefore, 2P ang ako ang gamiton diri. The area would be, what is the area of our shaft? What I given? Okay. Now that I given nga diameter, that's 60 mm. So, if that I given nga diameter, therefore, basin... Anyway, let's check. Pero feel na ako nalipatan. Anyway, let's just check later if sakto ato answer. Okay, so, area of the rod would be 60 mm. So, 0.25 pi. The diameter is 60 squared, mm squared. Therefore, makancel si area or squared millimeter. So, what would be the value of our P? Due to normal force, that would be 55 multiplied by 0.25 pi times 60 squared over 2. So, that would be 7,754.418 Newton. So, that would be approximately equal to 77.75 kilo Newton. P. So, to be safe, alright? Since to be safe man ta, kung mag-design, manin naman diba? Kung ganina, nag-design ta og area, alright? If we design the area, you should always be rounding up, pataas. Pero, if you are going to design forces, you should always be select the least force to be safe man ta. So therefore, ang atong gamiton diri nga force is kaning mas gamay. Kaya nga naman, if gamiton na to si 120, kanigod, due to normal at 77.75 kilonewton, mo fail na good ni siya. Right? Mo fail na good ni siya. Diba? Mo fail na good ni siya. So therefore, di na to siya pwede gamiton si 125. Kaya nga naman, kung ato ni siya gamiton, mas labaw nga mo fail ni siya. Right? So 77.75 degree. I mean, kilonewton. So muna to gamiton nga value. To be safe, that would be use P is equal to 77.75 kilo Newton. Okay? So, basin ako nalipatan. Let's check if we have the same answer. So, it's wrong yun. So, na ako'y something na nalipatan dire. I guess sa bearing nga part, ito ha. Sa bearing na part, yung ano man, the area, mulagi, kay since naman na siya, naman na tayo given ganina nga diameter sa rod, therefore, kaning 80, ang mahitabo sa ato ang contact area karon is donut jud siya. Oops. I hope nakagets mo. Ang ato ang contact area karon diri kay ganina, ang atong gigamit nga contact area kay ang tibuok nga 80 mm, di ba? Ang tibuok nga 80 mm diameter na gigamit. Pero since naaman daytay shaft, alright? Bali ang porma sa color karon is mura siya donut gyud siya. Sorry if dili siya perfect circle, pero mura na siya donut. Alright? Nga ang ato ang inside diameter is 60 mm, di ba? Meaning, mura siya sing-sing ba? Alright? Or, I don't know if nakakita na mo mga nut sa mga bike, mga motor. Nut na siya forma. Meaning, mura siya the best example is nut or donut. Alright? Naka-donut siya. Meaning, naa siya'y buho sa tunga. So, this is now the contact area with our color. Right? With our color and our journal at B. Kani siya. So this would be our contact area. So let's try if we will arrive with the same answer, with the correct answer kana na sa ubos. If ato na change ang ato ang contact area. Now the contact area now would be, ako na siya i-delete ha. If gusto mo makabalo sa pili unsay value sa akong gi-delete is you just go back to the video. Ako lang siya i-delete kay murag nasayop ko og analyze ka ganina. Moto nga murag kabalot na sure jud ko nga sayop ko. Okay? So this would be your P now would be equal to 75 mahimo ning 0.25 pi multiplied by 80 squared minus 60 squared. The unit is in mm squared. Therefore, what is the P? 75 multiplied by 0.25 pi times 80 squared minus 60 squared divided by 3. The unit is 75.25 pi 54,977.87 Newton. Therefore, this would be equal to 54.98 kilonewton. So, wala gihapon. Pero mas lesser siya. Kumparaan ni, di ba? So, mas doon siya sa 51. Now, what is wrong with this? Let me just analyze. What's wrong with this? Okay, if you're going to compare this, so murag sakto ato ang bearing, wala tayo laing murag mo na gini siya. Sa normal, so normal 2p, ngano 2p man. So if you are going to cut a section here, this would be 2p. Dire would be okay. So this would be, if I'm going to cut a section here, 2p. 3p po ni siya. Okay. So our value for the normal is 3p gihapon, dili 2p. Okay, method of section di ay, sorry. Method of sections gihapon, ang pinaka-critical diri nga section AA to EB is CEB. Nga naman, diri ang ato ang AE is ga-resist lang siya og 2P, but for EB is ga-resist siya og 3P. Okay? 3P gyud gihapon siya. So therefore dili ni siya 2P. So 3P din ni siya, sorry. 3P ni siya. 3P. So therefore this would be wrong. Pero feel ko muna ni siya. Sakto na ni siya. 3P bitaw, sakto. By method of sections, right? By method of sections, ma-solve na to si 3P at section EB. Okay. So let me solve 55 times 0.25 times 60 squared divided by 2. Sorry. Divided by 3. That would be 51, sorry, 3 ni siya. 51,836.279. So this would be approximately equal to 51.84 kilonewton. And again, use the least value of your force in the design. So mas ato dakuan, mas ato less ang force. So therefore use 51.84 kilonewton for P. And this would be our answer. So sakto na gyud siya. 3P ra gyud gihapon ang gamiton for your normal. So malanto siya. You just have to investigate kung asa ang possible nga mga failure dire. Right? So ang medyo ang kinahanglan niyo dire is not just your analytical skills but also your imagine ba? Right? Imagine nga asa man jud kung mo niya akong system, asa man ko possible nga mag-fail, and kung asa ka mo fail diha ka mag-design. Nga ra man siya mas critical, di ba? Nga ra man siya mas critical, so therefore diha ka mag-design. Okay, so that is your example number 13. Next example would be, I guess this is the last example. The rigid bar AB shown is supported by a steel rod AC having a diameter of 20 mm. So AC is 20 mm. Single shear. CA o CC dara. Ang side view niya is single shear lang. And an aluminum block having a cross-sectional area of 1/8 square millimeters. So kani, that is a normal support. The 18 mm diameter pins at A and C area are subjected to single shear. So based sa figure, single shear gid siya. If the failure stress If the failure stress for the steel and aluminum is 680 and 70 MPa respectively, and the failure stress for each pins is 900 MPa, determine the largest load P that can be applied to the bar. So steel. Okay, so let's solve this problem together. So wait, let me just copy the given so that we can have. So in this example, if mo lang sabton ang problem, makakuha din ka diha kung unsa ang mga possible nga failure nato. Okay, so let's move to our solution. Okay, so there is, since we are given with fail of steel, for the steel is 680 MPa. Now the normal stress failure at the aluminum is equal to 70 MPa. Then for the shear for the pins, failure ni siya gihapon is equal to 900 MPa. Now we are going to use a factor of safety of 2. Okay, So, ang gamit diri sa factor of safety is ma-solve na to ang mga allowable. Kay again, for the design is we are going to use the allowable. Alright? Allowable na to nga mga loads since we are solving for P. So, what would be the allowable here? Sa steel, using the formula, diba? Your fail over allowable is equal to your factor of safety. Therefore, your allowable is equal to fail divided by the factor of safety. Therefore, that would be 680 divided by 2. So, 340 MPa. Yan na lang siya paggamit. For your aluminum, that would be 35. Aluminum, that would be 35 MPa. Now, for your pin, allowable, that would be, kung 900 na siya, that would be 450 MPa. So, mo ni nga mga values ang ato gamiton sa ato ang design. Okay. So, what are the possible failure? First, mo fail ni siya due to normal force. So, kani. Right? Mo fail ni siya dari. This would be our failure 1. Sunod, maputol ni si steel. Diba? Maputol na si steel. This would be our failure 2. Ikaduha. Okay? Since 2 force member man ni siya, so whatever force nga ma-solve ni mo diri, mao gyapon ni nga force i-solve ni mo diri. So the third failure nato would be your maputol si pins, either A, si C. Parehara man na sila. Si A ug si C will be experiencing the same force manggihapon na. Alright? Kay 2 force member man na siya. So whatever force nga naa ni A, that will be the same force nga naa ni C. So mo fail na ato ang pin, that would be our third failure. Again, mo fail si aluminum due to normal or bearing. Si steel is due to normal. That would be our second failure. And then si pin mo fail at the 3 due to shear. That is why we are going to use this data. Dili na siya always dili na siya basin mo yun siya tulo ang given so tulo pud ang failure. No. Nayusahay nga ang usa ka given is daghan nga failure siya pwede ma-apply. Okay? So dili siya safe nga mo ninyo basihan nga ay tulo ni ka failure kay tulo ang given. No. Timing lang siya. Pero not all the time nga kung pila given mao pud ang failure. No. Okay? Mabalaan na siya is as you go solving problems. Okay. So let's start aluminum using aluminum. Okay, so dili pa dito ka-design because we don't have yet the internal forces. So let's start solving your internal forces in terms of P. Okay, so summation of moment at A na lang ko. Clockwise moments are positive, so we'll be having P multiplied by 0.75 minus B 2. So na diri B, then na po diri si AC. Pababaw, tension man na siya. Is equal to 0. So therefore our P in terms of P, our B in terms of P is 0.75 divided by 2. That is 0.375 P. That would be our equation 1. For the summation of forces Y is equal to 0, upward forces are positive. So we'll be having your si AC, di ba? We'll be having AC plus your B minus your P is equal to 0. Kung naman siguro line forces diha, wala na. Okay, excuse me. So we'll be having AC. The value of B is 0.375 P minus P is equal to 0. Therefore, our AC in terms of P, that would be 1 minus 0.375. That would be 625, 0.625 P. This would be our equation 2. Okay, so now we are going to design aluminum. For aluminum, Ano mo, sige mo siya dagan. Diri na lang. So, for aluminum, the area, the stress is equal to a force or P over the area. The normal, as per given, the normal for the aluminum is 70 MPa. That would be Newton per mm squared. What is the given force at the aluminum? That would be 0.375 P over. What is the area of the aluminum? The area of the aluminum block is 108, 1,800 mm squared. Therefore, makancel si mm squared. So, what would be the value of our P? That would be 70 multiplied by 1/8 divided by 0.375. So, that would be 300. Ako na siya i-diretso, that would be 336 kilo Newton. Okay, so di pa na siya mga to final answer. Kaya wala pa na to ma-determine ang uban. Oops, solo. Now, second for the steel, for that would be same gihapon. Stress is equal to force over area. Now we are given with steel that is 680. 680 Newton per mm squared is equal to what is the force acting on the steel, that is AC, 0.625 P over what is the area of the steel, 20 mm. So 0.25 pi 20 mm squared. So therefore, makancel na sa mm squared, ang mahabili na to is Newton. So what would be the force for the steel, using the steel? 680 times 0.25 pi times 20 squared divided by 0.625. Ako na siya diretso kilonewton. That would be 341.805 kilo Newton. So dili pa ni mong final answer na to. Naapatay aluminum we have for the pins. For pins, shear stress is equal to P over A. Now, what is the shear stress allowable? Okay. No. We have listed, we have listed for the factor of safety, so we are not going to use the failure. Okay? We are not going to use the failure stress. Dapat ang allowable ato gamiton kaya naman tayo factor of safety. So therefore, wrong ni siya. Ako ni siya alis dan. The same also here. So delete po ni siya 680. I guess nakasuwat na ko ni ganina. We have dara. Oops. Okay, basta man na siya. For steel, for aluminum is we have 35, then siya 35 MPa. Okay, since naka-factor of safety naman na siya. So 35 multiplied by 1/8 divided by 0.375. So we are going to use P is equal to 168 kilo Newton. For your steel, we are going to use 340. Oops. Sayop ka. Sayop ka, girl. This would be 340. So 340 times 0.25 pi times 20 squared divided by 0.625. Then ako na siya i-convert diretso to kilonewton. That would be 170.903 kilo Newton. For pins is we are going to use the value of 450, right? So 450 Newton per mm squared is equal to your shear force. Since single shear man ni siya, so that would be equivalent to your AC gihapon. Single shear man na siya, so 0.625 P. 0.625 P over the diameter. What is the diameter of our pin? 18 mm diameter. Darha? 18 mm na sa ubos. So 0.25 pi 18 mm squared. Therefore, what is the value of our P? That's 450 times 0.25 pi times 18 squared divided by 0.625 divided by 1,000 para kilonewton diretso. This would be 183.218 kilo Newton. Okay. So, based sa itong tulo ka situation, we have your aluminum, your steel, and your pin. Is kinsa may pinakagamay og force nga nga required. So, therefore, ang pinaka-weak na to karon si aluminum. So, therefore, we are going to use your aluminum. Therefore, this governs. Right? Governing na to nga force is si 168 kasi siya man ang pinakagamay nga force. Okay, so I hope sakto ni siya. So let's check if we have the same answer. Okay, so sakto gid siya. Ang atong governing nga condition is si aluminum. Siya ang pinakauna nga mo fail at 168 kilonewton. This is 170, this is 180, so therefore aluminum. Alright, so I guess that's the last example for this video and for this module DI. Alright, that is the last example for this module, so therefore within this week or next week, we will be proceeding with the next module. That would just be a short discussion lang. Okay? So, prepare for assessment number 2. That would be on Wednesday, May 5, and that would be until May 6 a.m. The same video hapon. Then the coverage would be this video. Whatever that we have talked in this video is mo na siyang coverage. Basic design of structural members using the concept of stress. Okay, so if you have some questions, again, if you have any questions, feel free to ask. You can use your Freedom Wall if you want. And also you can send an email regarding this one. Okay? So that's the end of our module. So your first problem set will be released soon. Okay, so maybe this week siguro I'll be releasing your problem set number 1 so you can have something to practice. Okay, so I guess that's the end of our video. So see you on our next meeting. Bye.